What would be considered the optimal percentage when it comes to evaluating the quality of the application? This particular question has been coming up frequently as of late, especially after we published the most recent video concerning the application of the aircraft, both with the utilization of the flow meter and without the utilization of the flow meter. This particular question emerged with numerous inquiries attempting to comprehend, but what exactly is the ideal scenario then, since now we have the capability to measure and understand all aspects of deposition, application coverage, wind speed, and all the meteorological data related to the application, integrating with the application data itself, and subsequently triangulating all these data points. Many uncertainties arose concerning this specific matter. What percentage should I consider as favorable or unfavorable? Which parameter should I start delineating in my analysis to effectively determine whether that application is considered acceptable or not? So, I began with this particular map for you, specifically this detailed heat map concerning the flow. Essentially, we will conduct an analysis of the flow here. It will involve utilizing the automated flow control system, more commonly referred to as a flow meter. And we shall comprehend what this percentage signifies. Let us collaboratively construct this concept of what constitutes an acceptable percentage, what is deemed unacceptable, and what the comparison is without employing the flow meter, and subsequently with the utilization of the flow meter. To provide us with a comprehensive understanding, if we utilize this particular application as a foundational basis, from the instant Travicar Connect elucidates this to you, clarifying the quality of the application, what thoughts or considerations arise in your mind? Well, Felipe, what percentage is deemed sufficient in this context? If we examine this particular application, it actually possesses an accuracy rate of 89% when compared to the intended outcome versus the actual result achieved. Let's begin with the initial uncomplicated analysis. The average application throughout this entire polygon was 19.9, whereas the goal was to achieve 20. Consequently, on average, it was 100% efficient. This data set, when considered independently, is primarily employed from the moment I begin utilizing the flow meter. I am capable of quantifying that over the entire duration, throughout the whole region I plan to operate within, and all the liquid used for spraying. I successfully performed a calibration using the flow meter, attaining an average of 19.9. This indicates that the volume, when divided by this entire area where it was applied, will represent this average application calibration. So I successfully achieved my goal, as I aimed for 20, and it resulted in 19.9. Now we proceed with a more comprehensive analysis of this entire application. At this point, I want to understand throughout this entire area where I applied more than 20 and where I applied less than 20. Then I begin to evaluate myself by stating that 20 was the target I was striving for. I am not striving for a target of 22 or higher, nor am I striving for a target of 18 or lower. What is the implication of this statement? The aircraft will experience fluctuations in its operational speed, and the flow meter efficiently resolves this speed-related challenge. This represents a parameter. However, if we take into account a specific area, such as a polygon, we will come to the realization that its delineation is not an idealized area. It is neither a flawless rectangle nor a perfect square. It is not an area where I can effortlessly commence at one point and conclude in a perfect area at the end, in other words, in a straight line. Straightforward at the commencement, straightforward at the conclusion. It is not as we observe here. Consequently, when we arrive and begin to notice that all the areas possess certain boundaries, the aircraft must assume an application position that is appropriate to execute this task more swiftly and with greater precision. I inevitably cannot prevent edges in the task. So these specific points, in reality, what function will they serve? They will reveal certain inconsistencies in the application process because it is impossible for the aircraft to apply with absolute perfection. The average of the strip that I will establish, for instance, for application in this scenario, let's consider this particular example here, this strip 1 here, or strip 0 here. If we base it on the strip itself, it needed to execute a brief application here, thus creating space for a shot. However, if we conduct a thorough analysis, the strip in this particular instance ought to be configured at approximately 24 meters of application. If I contemplate the necessity of covering approximately 24 meters at this particular tip of the polygon, automatically there is a possibility that I might not be able to successfully reach the application and commence and conclude this pass, for instance, by covering either 20 meters or 24 meters of this designated area. I will cover it because it's an edge, you understand? So naturally the 20 meters that I intend to apply, which I previously mentioned is the range, Perhaps 10 meters will extend beyond the border. Here at the tip, a portion remains inside, another at the beginning of the pass, it intersects and so forth. Why is he going to do that? Because it's not an exact measurement. I'm going to go with 20 meters in a linear way, but if I get to this point here, for example, and go to spray, I'm going to do 20 meters here, but you see that I might have the tip of the wing outside the area and the rest also outside. This will be considered an error in this application. Why will it be considered an error? Because the system will perform a standard measurement, and we are going to take a geometric polygon, and the polygon exhibits variations. So essentially, what do we need to take into consideration? Prior to having a measurement and automatic correction tool, I was quite close to this situation here. Why was it exceptionally close? Because this specific area had already been treated and a flow measurement device was utilized. In other words, an instrument was already employed to assist in the precise calibration of the aircraft, yet it was missing an automated correction mechanism. Essentially, this pilot who managed this specific area had the parameter on his GPS indicating what the flow rate being applied in liters per hectare was during that precise moment of application. And for sure, he could go to the bypass and make some adjustments. Right now, in an application without a flow meter, without an automatic flow correction valve, you are flying with zero information. So the sole piece of information available is the quantity of product contained within the tank, which is referred to as the hopper of the aircraft, in comparison to the duration and the expansive area I intend to cover. So if I am in the process of refilling the tank, applying, refilling the tank, applying, and I possess no information about the flow that is passing through, but how was this control managed? Of course, there is control, but they are more analog. The control is based on pressure. So the first thing you need to do is assess what pressure you will stabilize during the application. However, the pressure that you are stabilizing is specifically to establish a parameter in relation to a constant speed. Nevertheless, the speed of the aircraft is continuously fluctuating. Thus, that pressure parameter serves merely as a reference point. It is not an unchanging factor. Indeed, it will fluctuate continuously. So for instance, if I arrive at this particular area and take into consideration that even while observing, being aware that I could make corrections, and indeed there ought to be adjustments amidst this, because the pilot was observing how much he was making errors, we only attain a 42% level of accuracy. That is, but Felipe, what is accuracy? Hitting 20 liters per hectare. In other words, when it is below 22 and above 18, there is still a pre-established variation within this particular area. But what exactly do I mean by this? What is the size of the error when I don't have a flow meter? It's definitely larger. I will hit much less than 42% of the area. But what does hitting mean? Achieve the flow rate that I should have established from the very start. Oh, but does that imply my area will be poor? Not necessarily. I might have some remaining mixture and consistently apply more than I initially sold. So if I was supposed to make 20 liters and I make 22, I will have applied more than needed. Is it ideal? No, it's not ideal, because what was planned was 20. The dosage of the medicine is set for 20, so there's no reason to waste with 22. It's a loss of money, an extra chemical, a waste of the plane's time, and so on. In any operational undertaking where the primary goal is not completely achieved, all involved parties experience a hindrance. Essentially, once I establish a reference point, I obtain a tool for assessment, and I require a specific criterion to ascertain exactly what. The amount I had in my possession previously and the quantity I currently hold. Therefore, any percentage exceeding 75%, 78%, 90%, from 80% and above 85% and higher would constitute an exceptional area. Naturally, we will conduct a thorough evaluation. But Felipe, you have areas that you have already shown here that achieved 98% efficiency. Yes, it achieved 98% efficiency because the area, the polygon, is well constructed, has far fewer corners, far fewer areas, complicated parts of application, or short strips like this example here. Thus, automatically, you can achieve significantly greater precision. Now, will anyone attain an absolutely perfect 100%? Clearly not. Of course not. What is 100%? 100% means the plane doesn't deviate a centimeter from its application line. That's impossible. Even if we took a machine, a drone, for example, which is remotely guided, it also wouldn't be accurate. It would also have variations because there would be wind pushing it, and it would have to correct its course. Therefore, we cannot become overly concerned with these fluctuations, these percentages of precision. What truly matters, it is to transition from a calibration precision of 30%, 35%, 40% to a precision of 89%, 80%, 75%, 92%, 98%. It is an additional and somewhat absurd parameter. So what guarantees an application in this context when I possess all this quality of application? I am aware that what I intended to apply, the dosage I plan to utilize for the treatment, was indeed applied accurately and correspondingly. By utilizing these advanced tools, particularly the automated flow control system, what advantages will I obtain? Here is the equipment, which includes the flow meter. Thus, I possess a flow reader along with a correction valve. In the map that I presented to you, where there was solely reading, this subsequent piece was detached and only the reader was utilized. Consequently, the pilot had access to information here on the GPS regarding the flow rate that was being transmitted. So he kept the ability to make manual corrections, but I assure you, with an automated valve, this situation multiple times every second. Thus, this adjustment is exceedingly rapid and precise, so much so that we achieve 98% to 99% in coverage control application. 19.9 as we observed in that particular application, correct? We are going to arrive here, take a look, 19.9, do you see it? So if you examine this, the average of the application without utilizing the flow meter was already at 18.7. So we have here an average of 1.3 liters less than what should have been applied. So you use less product than what should have reached the field here in the 19.9 application. So when I start getting into the GPS accessories, I begin to approach a different way of doing a job well. So for any farm that has its own plane or a farm that hires a service company, what do you need to take into consideration? Maintain precision with the equipment that is available at your disposal. Ensure accuracy in what you will be capable of measuring following the application process. But what is the significant fact? Am I going to consider 100% as the standard? Obviously not. No one is going to be 100%. A machine won't be 100%, and so on. So there are many variations in an application. The polygon may not be entirely filled, which could either add to or subtract from the deposition within the designated area, meaning it will not reach a perfect 100%. There will be variations in wind that could cause the plane to shift slightly from the intended shot it is executing, from the strip it is applying, resulting in, let's say, certain gaps between the strips. So we will look at this. This was all an area that was not covered. But this area, then comes the second question that we often hear. But if there are gaps here, this wasn't efficient, this was very efficient, then we will have to understand. If you use Travicar Connect, you can measure how much this is. You'll open the program and you'll measure it. How will this information be relevant? Every agricultural aircraft, each aerial spraying operation, commences with the presumption that you delineate a specific strip that you intend to cover. Nevertheless, this strip that you plan to cover, let's contemplate that this piece of leather here represents the strip I will cover. What is crucial to comprehend that the application area will indeed be more extensive than initially anticipated. How much more extensive is it typically? On average, the aircraft possesses an additional 2 meters to the left and 2 meters to the right for extra application. Why does it possess that? Certainly, within the scope that I established, let's consider the instance of the Ipanema 203, where the typical range measures 24 meters. What action will it undertake? Its effective range will extend to 28 meters. It might be 29 meters, or it could be 27.8 meters. What is this information of 28, for example? That I have 2 meters to this side, 2 meters to that side, which I will ignore. Why will I ignore it? Because in this particular area, the flow is gradually diminishing. Therefore, within the range that I have designated as my effective application range, I possess the equilibrium of the volume of droplets that I am dispersing across this entire strip is crucial. So if I consider this entire strip, I have a uniform droplet distribution, and I maintain the correct high volume, ensuring everything is optimal there. However, at the edges, the volume begins to diminish. So I will disregard this section where it started to decrease. Essentially, these gaps here are covered by 2 meters when I'm passing by, and another 2 meters when I'm returning. Thus, this was thoroughly covered. With complete certainty, this area is sealed and was entirely applied, or the chemical reached every part. However, why does not registering everything lead to this gap? Due to factors such as wind, the pilot might deviate from the intended application path, causing the aircraft to shift more than necessary, which subsequently begins to form streaks along the trajectory. But if you measure, it will be like this. It will be 30 centimeters, it will be 20 centimeters, it will be 50 centimeters. But even if it's 1 meter, even if it's 2 meters, it was still covered. You have to be very sure that aerial spraying is extremely safe and extremely precise. When we compare it with other methods of application, you can be certain that what you will do with the airplane, you might not be able to do with other machines because the airplane is extremely precise. The equipment is precise, the way of measuring everything is precise. So what will you understand? What do you have with the availability of accessories? The DGPS Travicar, what do I gain by using the DGPS Travicar? What is the advantage? Where can I add a series of high-performance accessories to truly keep the entire plane in balance, the entire application in balance, so that I can subsequently transfer it to Travicar Connect and obtain the comprehensive parameters of flow rate, application, altitude, velocity, wind speed, wind direction, and all meteorological information. So what's important is that sometimes you outline information that you want with precision, but you end up not being able to measure it. With Travicar, all Travicar equipment can be measured through Travicar Connect. So you have all the data in your hands. What does that make you? It provides much more precision, much more objectivity in the work, much more speed, and much greater efficiency in the aircraft for the pilot. So through the platform, he can make application plans where he has all the mapping, everything in advance, and he has all the planning already defined, the best entry into the run, the best exit, the shortest time for turning, the shortest time for how he will lose time making turns, lose time refueling and returning. So he can study all of this within the program and make his application precise to the point where he understands where he is losing time. Evidently, he will never compromise flight safety as the pilot maintains comprehensive control over the aircraft. What benefits will he derive from this? He will acquire enhanced directional accuracy. For instance, if he plans to follow a line to reach the application area, starting from the base, and he begins veering off, making a loop, electronic tracking will prevent that. He will plan and draw a straight line to the application. Then he will make the flight much more precise, set the cruising speed, and arrive there much more accurately. He won't waste time with unnecessary maneuvers. Therefore, you possess a collection of tools today, and it is exactly at this juncture that we introduce this comprehension. Consequently, you will never experience an application that will achieve a perfect 100% because 100% is what the computer will accomplish. With all optimal parameters set, where will you find an airplane? It will be very near what's considered the ideal location. What is the ideal? Above 80%, 85%, 90%, each farm, each group will create its own standard of ideal. But what does an ideal standard mean? Essentially, it signifies that within our regions, our territories are relatively straightforward to manage. They are expansive, possess fewer boundaries, and the aircraft will encompass an expanse of approximately 1,000 hectares. The strips are elongated, necessitating only a few passes over a significantly vast area. So a series of variables, if I go out, for example, and take Rio Grande do Sul, make a map comparison of Rio Grande do Sul, surely the map of Rio Grande do Sul will be here at 89%, which is the example of this application here. So what exactly are we going to extract from this foundation? There's no possible way I can enhance this. This application is outstanding. It truly merits a star for this application here. Why? Because the areas in Rio Grande do Sul are all fragmented, see, full of edges and all small areas. So the average division of a small correction area and so on will always have the worst for the operator. I start moving to slightly larger areas. São Paulo, then when I get to Mato Grosso, indeed really large areas, areas prepared for airplanes. Pará as well as Bahia too, I will observe a significantly higher percentage of efficiency, but then you might ask, but why? So if I have reached 98, my contractor is articulating that a score of 98 is inadequate. Nevertheless, the contractor must acquire a more profound understanding of the information being conveyed to fully comprehend how they will ascertain or determine what is worth improving from what they presently possess. So first point, you're doing everything wrong. You get a measurement parameter and you want to earn a gold star by hitting 100%. Forget it, that's not going to happen. That's not real life. Even a race car driver who would have the entire track memorized doesn't get it 100% right. So how can we expect that an airplane pilot is very precise in a fast-moving spacecraft? There are variables he won't control, like the example of polygons. Therefore, we must remain exceptionally grounded at this juncture. With all these numerous variables, what truly matters? You have distanced yourself from significant errors, correct? And this one I'm saying was still helped because there was information for absurd tasks, right? We're seeing the green predominant in the application here. Am I going to create a case? Felipe, but at the start of the shot, there's a larger volume here, right? How does the airplane work? The airplane enters the shot while the agricultural one will be completely stopped. It doesn't know when it will start working. So he stays put. He gets to the polygon using an auto flow valve, a flow opening valve, which is this extra part here with automatic on-off function. He will reach the edge of the area and it will open. He will finish the edge and it will close. All right. Up to that point, everything is fine. But what is he going to do here? When it opened, the plane might be at speed. He might not necessarily be at that exact velocity. He will likely be at a somewhat different speed when he concludes the shot. So automatically, and there's also this particular aspect, when the spray pump or the pressure pump is halted, and then you release it to commence functioning, it will provide a surge of pressure and volume of liquid into the system that will spray. Automatically, the system experiences a surge of pressure and subsequently stabilizes. This period is known as the stabilization time. If we observe attentively, we can discern that there was a curve. Initially, when it opened, it was insufficient. Then it filled up and promptly stabilized, and everything continued to remain stable. Here, we can observe the real-time correction of the flow meter displaying this particular shot here. We can examine this. This shot is distinctly marked. So what do we have? There was a peak here of up to 24 liters. Of course there was, here it is. Then it stabilized and went on. So what do you have today? But what is it like when I don't have this? Well, this is precisely it. When I am without this, I ought to be achieving 20, yet I did not reach 20. Observe, I accomplished 15, then 18, and ultimately concluded with 18. I am unable to even perform what I am supposed to be accomplishing. Why was the target not achieved in this instance? It is quite straightforward once more. The velocity of the aircraft exceeded the speed for which the aircraft had been calibrated. So there was a shortage of product. I'm going too fast for the calibration I did, because remember, there's no automatic correction. There will be a shortage of product. I went too slow with the calibration I did. There will be leftover product. What do I see when I arrive at an application where I have correction? I balance what needs to be at 20 and it stays at 20. So that's what you need to understand. All this percentage, all this analysis, we start from the assumption that you had no information and now you have information. What should you absolutely not overlook to do and take into consideration? To utilize accessories that will furnish you with all this comprehensive monitoring, all this detailed information. Consequently, you will have a significantly more qualified crop, a crop with substantially higher yield, because you will understand how you executed the treatment, whether it was appropriate or not, because occasionally you might opt to work on an area even if it's not the most ideal time. And there's no problem. You adjust the equipment, you adjust the nozzles, adjust the atomizers for that adverse condition, and make the application. It will work perfectly. But then I have always mentioned, Felipe, that I was unable to apply at a temperature of 40 degrees and with 30% humidity. Well, there is equipment available that can accomplish that. They are extremely precise, and they actually work at their highest efficiency in higher temperatures and lower humidity, as is the case with electrostatic equipment, for example. So all of this has already been considered. What is lacking is the information available in the market to understand what can be utilized. So what is our job here today? Demonstrate everything that can be accomplished with the equipment, the methodology of thinking, and the approach to compiling all this information, as it holds significant importance. I am entirely confident that the more you make use of tools to your advantage, without getting caught up in the details, without trying to find someone to hold accountable for anything, because once again, there is no single person to blame, there are strategies to implement, there is application quality that you can improve to the utmost, and that is the reality. So, if your reality is 85%, that's great for us, you understand? Let me give you an example. If you have 3 or 4 companies in your area that do spraying and all of them have the same percentage, would you say that everyone is bad? No, you will comprehend that the average of your specific area, its potential, is that particular percentage. So could it possibly improve if I modified other parameters? Sure, it could get better if I worked on more areas together, expanded more, avoided small polygons, and reduced edges. We must understand that Brazilian agriculture varies greatly from state to state, and this particular mindset must also accompany the operators, the agronomists, and the digital IT teams working on the farms as they need to comprehend. Should there be any uncertainties, seek guidance, and we will elucidate it, as it is also our responsibility to demonstrate how to think, how to understand each tool that is accessible. So, here is a crucial point that we have outlined for you. I believe it was thoroughly explained, and immediately, we don't even need to spend time unnecessarily. What is preferable? It is not even comparable. Therefore, we will be able to discern the difference between utilizing automatic flow control and not utilizing automatic flow control. This is the reality we are confronted with today, and we must persist in implementing ongoing and continuous improvements on our farm and within our service printing companies. This is significant. If previously I was committing errors 50% of the time, now it's 40%, then 10%, and currently 5%, correct? It's all about minimizing mistakes and enhancing precision. And then we'll always have a growing company, a farm that's always getting better, and so on. So this mindset is how Travicar works internally too. Sometimes you need to make progress in a sector, and it's no use thinking you'll arrive and revolutionize it. The sector will evolve gradually. You have to address the cultural aspects, show why something is wrong, make improvements, evolve, and make corrections. Over the course of 30, 60, 90 days, we can achieve the improvement of the sector. So it's very similar to the field, it's very similar to what the application was. Our goal is to make sure the information gets clearer over time. So if you face any doubts or challenges in understanding, before gathering any wrong info, please contact Travicar, reach out to me at Travicar, and we will explain each situation clearly and accurately, ensuring it's transparent to everyone involved. But I wanted to do it. Well, you won't be able to do it. We can evaluate these areas for you, send you an analysis, and see what you think of this application. We perform the task, transmit it here, and execute it. What is the reason for our actions? It is because we must demonstrate where you can still request a correction or not, whether it functions effectively or not, and illustrate which equipment you could procure to optimize the utilization of your technology. And indeed, what truly matters: a significantly larger harvest, a considerably more productive crop, a notably more abundant crop, and so forth. So this is how we'll work, this is our method, and there's no point in trying to do everything. Thinking a percentage is the standard for all info. It's a matter of growth and education. So we provide you with all this information. If you have more questions or doubts, send them to us, email us, message us directly, reach out in any format, and we'll clarify things for you through videos, or we can call your company to clarify as well, hold meetings, and so on. We are open to engaging in this type of dialogue to thoroughly instruct and share our extensive expertise and comprehensive knowledge with the marketplace.